Okay, here's some review of grade 10 that you're expected to know and be able to do, and I will be quizzing you tomorrow on today's stuff. Sketch a graph of each line, labeling the y-intercept and slope. So, to sketch a graph, you need an xy axis. Technically, you should put arrows on them also. Now, this line has a y-intercept of 5, which is the point 0.05, and a slope of 3, and slope is always rise over run, so it's actually 3 over 1, because 3 divided by 1 is still 3, the value is the same, but now you have a rise and a run. So first you plot your y-intercept of 5, and then that slope, this is just a sketch, so it's a positive slope, so it goes up. And it says label y-intercept and slope, so we're just going to say slope is 3 over 1. That's good enough for labeling it. So y equals negative 2x plus 1. Technically, you should have arrows, label your x-axis and your y-axis. What is my y-intercept? It's always the number that's not with the x, so positive 1 is my y-intercept. Got a point there. And my slope is negative 2 over 1, so my slope is negative, so that's going to go down, and my slope is negative 2 over 1. Over here, my y-intercept is negative 4, so that'd be down here somewhere. So that is my y-intercept, and then my slope is 0.5 over 1. Or somebody would say, oh, 0.5 is 1/2. Those mean that would be the exact same steepness of a line. If you go rise 0.5 and over 1, or if you rise 1 and go over 2, either or, you're still going to have the same positive slope. Oh, and we forgot our arrows, and our x's, and our y's. So that's reviewing sketching lines. Now number 2 says, write an equation to represent each situation. Also define x and y. So the cost of a pizza increases by $1.25 for each extra topping that is added, spelling mistake. A basic pizza is priced at $5. Eric is ordering a pizza for his math class. They agreed to choose at least 2 toppings, but they may choose up to 8 toppings. Okay, we're just going to deal with that first part. This is the cost of a pizza. So if you think of it graphically, the cost of a pizza is going to start at $5. Cost of pizza in dollars. And then it's going to increase by $1.25 over 1. Over 1 what? That is the question. And that answer will give us the title of our x-axis. Because this is our y-axis and this is our x-axis. So, the cost of the pizza increases by $1.25 for every what? That's right here, $1.25 for each topping. And the words for each are our slope words. That tells us where our slope is. For each, for every, per, those are all slope words. Per, for every, for each, or the per sign, $1.25 per what? Per topping. So the name of our x-axis is number of toppings. So the cost of a pizza increases by $1.25 for each topping that is added. A basic pizza is priced at $5. Write an equation to represent this situation. Well, we know y equals mx plus b, where m is your slope and b is your y-intercept. And we know our slope is positive, and it's $1.25. You can put the 1 if you want. And we know our y-intercept is positive 5. So there's our equation. Now here's the good news. You have already defined x and y because you showed the x-axis is called number of toppings and the y-axis is called cost of the pizza. So I'm not going to make you write it over again. If you showed it on a graph, you're good. The total cost of a night out at the movies for one person includes $9.50 for the movie ticket and an additional $3.75 for every treat purchased. So for every is our slope words, and $9.50 for the movie ticket. Well, if you go to the movies, you're going to pay $9.50 just once for the ticket, and then say you buy 3 treats, that's $3.75 times 3. Say you buy 5 treats, that's $3.75 times 5. So you figure out for your homework where your slope and y-intercept go in there, and you can even sketch it and label titles for your x and y axis. We are going to do more for this too. A car is purchased for $12,575 and its value decreases by $1,200 each year. Anne's car is anywhere between 7 and 11 years old. So her car starts at a value of $12,575 and it decreases. So it goes down. So this is our x-axis, this is our y-axis. Well, we're talking about value of the car in dollars. And it decreases, so its slope is negative because it decreases $12,575 per one what? Each year, per 1 year. So this is number of years for our x-axis. So per what tells you the title of the x-axis. Per what? Y equals mx plus b. Our slope is negative 12,575, and our... Oh, no. I made a mistake. Did you catch that? It decreases by $1,200 per year. So our slope is 1,200, and it's negative because it's decreasing, and our y-intercept is plus 12,575. There's our equation, and we labeled our x and y-axis. Good. Okay, now we'll review parabolas. Sketch the following parabolas, labeling the x-intercepts and the y-intercept. So, sketching a parabola, x-y axis. My x-intercepts are positive 3 and negative 5, because when you take information out of brackets in an equation, you change the signs. Or because x minus 3 has to equal 0 and x plus 5 equals 0, the way they're written here, but then you solve for x, which changes the signs. That's another explanation for it. So our intercepts are plus 3, minus 5. Labeling the x-intercepts, those are labeled with the numbers. And the y-intercept, well, because this is a negative right after the equal sign, that says this parabola is frowning. So this is going to be frowning. This one has a positive after the equal sign. So this will be smiling. This guy has a negative view of the world. This guy has a positive view of the world. And our x and y intercepts are negative 1, because you change the sign, and negative 2, because you change the sign. He is smiling, so this one's going to go like this. And you should put your x's and y's and arrows. There's a sketch. Write an equation to represent each situation. Oh, guess what? The equation's given to you. Also define x and y. So we're going to sketch, sketch, represent each situation. Define x and y. So, a ball is launched upwards into the air. Its height, h at t, is given by this equation. So normally we have y equals -3x minus 2x minus 6. So they've chosen to use h and t instead of y. That's just, instead of h, they put h at t because it's a function. We'll get more into that later. Just think of it as y. And x is now t. So this is like a t-axis, and this is a h at t-axis. So +2 and +6 are our x-intercepts. This guy is frowning. So the parabola goes like this. A ball is launched upwards into the air. Its height, h at t, is given by the equation where t is the time gone by in seconds. Now I just have one question for you. Where's the ball launched from? Is it launched from down here, which means inside the ground? Because this is the ground. No, the ball is launched from here, and it flies through the air. Does it sink into the ground? Nope, it stops right there. So that's going to be very important with some new stuff we're going to learn later on today. So the blue is the theoretical parabola, the black is the real life parabola that has to deal with this word problem. And real life usually happens in this quadrant. That's where real life happens. So, a golf ball is hit off the ground and its height in meters is modeled by the function blah, where t is the time gone by in seconds. So, golf ball. Well, this is the same as saying h at t equals -0.1944 t minus 0 times t minus 12. So this t here is like t minus 0 factor. So our x-intercepts are 0 and +12. Changing the sign of -0, I guess, is +0, but it doesn't matter if 0 is negative or positive. It's still in the same place. And the -12 becomes positive. So my x-intercepts are 0 and 12. This guy is frowning. So he's going to go like this. So that's the path of our golf ball. The theoretical parabola continues. The real life parabola, which depicts where the ball is actually going, is the blue part. Oh, we have to label our axes. So t is the time in seconds. I like to put x there anyway. And h at t, or y, is the height. Did they tell us it's in meters? Nope. Okay, they should have told us it's in meters, so that's an error on my part. You can just ask me or assume it's something, and I won't mark it wrong if I didn't tell you what it was. So in this one, we didn't name our axes. Ball is launched into the air. Its height, h at t, and it doesn't give us measurements again. We will assume meters. And t is time gone by in seconds. Always put the units in brackets because when you go to answer your questions, the graph is very useful. An object is dropped out of an airplane and its height is given by this equation where t is the time gone by in seconds. So, our intercepts are +11 and -11. So I'm going to change this a little bit, make more room, and call this +11 and -11. He is frowning. Oh. Let's do the G backwards. Okay. He's frowning, and parabolas are totally symmetrical, so your maximum point's actually going to be right there on the axis because the 11s are both the same amount, just different signs. So, an object is dropped out of an airplane and its height is given by this equation where t is the time gone by in seconds. So if t is time in seconds and h at t is the height, does it say in what? Nope. So I don't know. Assume meters or kilometers maybe would make more sense, say, if it's an airplane. So where along this parabola is that object dropped out of the airplane? When time is 0, the object is dropped. So once again, word problems happen in real life in this quadrant. That's quadrant 1. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. We'll get more into that in trigonometry. And label our axes. So time in seconds and height. And we're going to say, oh, I did that one already, kilometers. Okay, that's review. Here's the new stuff. The domain of a function. Actually, I'm going to pause it right here and make this into a new video just in case.